And here we are again, ready for another one of our videos today, talking a bit about the market structure of perfect competition. In the introduction, I talked you through the kind of four main assumptions or criteria necessary for a market to be considered perfectly competitive. And those conditions, you'll remember, involved having many buyers and sellers, having homogeneous or identical products, having having complete information, and having free entry and exit. So what I want to do today is show you how the model works to describe markets that meet those four criteria. And one of the things that Colander talks about is the fact that if you have those criteria met, and he has it as a separate item, I like to think of it as sort of an implication of those four criteria, you end up with buyers and sellers who are price takers. So what I want to do is I want to walk you through a picture, a combination of pictures, I guess. And in the left-hand picture, I'm going to draw a picture of the entire market. And the entire market, this is just going to be a supply and demand kind of story. There's quantity down here and price up here. We have a demand curve and, of course, a supply curve. And in this market, then, we have price and quantity determined where the supply and demand curves intersect. So the usual kind of story there. Let's call this P star, call this Q star. Sort of give ourselves a nice big dot there. So there's the equilibrium. And what happens in a perfectly competitive market is that demand and supply are determined by overall market conditions. But for an individual firm operating in this market, they have to take this price as given, right? This P star, whatever it turns out to be, is simply given information to them. They don't have a chance to set that price in any particular way. So what I'm going to do in the second picture over here is I'm going to draw an example of what things look like from the perspective of an individual firm in this market. So this is one of the firms that's included in this overall market supply curve. Now, one of the things that I always think about, hearkening back to my days as a graduate student in Indiana, was that I used to spend a lot of time out in the countryside riding my bike for exercise. And what happened when we used to go out on these bike rides is that you had to go quite early in the morning because it was, typically very hot and humid in Indiana in the middle of the summer, and so we'd leave very early in the morning. And one of the most kind of vivid memories I have is that I would occasionally turn on the radio, try and catch the morning news or a little bit of music as I got ready to go for my bike ride at 4:30 or 5 a.m. or whatever crazy time it was. And every now and then I would catch the farm report on the radio, and I don't know if you know what this is. These days it's probably all on the internet, but at the time the farm report was, I think, single-handedly responsible for keeping me working hard in graduate school, because I didn't want to end up as the guy who had to read the farm report. It was a very boring sounding job. And what I imagine, I think this is certainly the case, is somewhere in a studio in Indianapolis or Chicago or wherever the radio station was, there was some poor soul whose job it was to get the printout from the Chicago Mercantile Exchange the day before and simply read off the closing prices for just a huge variety of agricultural products. So each of those products was traded in a market like the one that we have on the left. The closing price for the day before, we'll just call that P star, and the farm report involves things like number one winter wheat closed at 11 3/4 yesterday. Summer hogs closed at, and so on and so on. So these prices are reported and they get projected out, and the firms are able to listen to these reports. And what this means, this idea of price-taking behavior, is that the firm simply takes the prices given. They can't do anything. Remember, there are many, many, many firms out there. Everybody, both buyers and sellers, are fully informed about what's going on in the marketplace, who's charging what, and so on. And so we have this flat or perfectly elastic demand curve for the good from the firm's perspective. Now, I'm using some lowercase letters in the picture on the right and some uppercase letters in the picture on the left. The idea is that this demand curve is for the firm's product. So if this is the market for corn, for example, this is what the market for corn looks like overall. The market price is determined by market-wide supply and demand conditions. Demand for corn from farmer A, from a particular farm, though, is far different, because everybody's fully informed. If an individual farmer decided they wanted to try and deviate from this market price, P star, they would have no success in doing so. Suppose that corn is currently selling for $12 a bushel. And suppose that I decide that I want to try and charge a different price. Well, if I come out in the market and say I'm going to charge $14, the buyers look around and they're fully informed. They look at other sellers and they say, well, that's no good deal. I don't want to buy it for 14 if I can buy it for 12 at any number of other sellers. So no sale for me. Likewise, if I decide I'm going to sell, say, at 10, that's great. A lot of people will come and buy from me, but I'll run out of corn before I run out of customers. And so selling at 10 just means I leave $2 per bushel on the table. So I can't sell for a higher price. There's no reason I would want to sell for a lower price. I simply have perfectly elastic demand at the price of $12. Now, in addition to that, I'm going to add to this picture, I'm going to add some kind of typical looking cost curve. So here's marginal cost. There's an average cost curve. Remember, average cost and marginal cost have to cross down here at the bottom of the average cost curve. And then I'm going to think about the decision rule that consumers face in this market. So consumers show up and they simply decide, do I want to buy a bushel of corn for $12? If I value it at more than $12, I buy. If I don't, then I don't. And those customers that are willing to buy are, of course, all of these guys right here, right? That's where they live on the demand curve. Now over here, from the firm's perspective, the firm's decision involves trying to decide how much on a particular day, how much to sell. And that's going to involve comparing the amount that I can get for each bushel to the cost that I have to pay for each bushel. Now it turns out that the easiest way to make this decision is to compare these things at the margin. So I'm going to compare marginal revenue to marginal cost. The idea is I get $12 for each additional bundle that I sell. And so all I do is I compare the $12 that I get, for example, here for bushel 1 to the cost that I have to pay for bushel 1. I discover that sure enough, there's a benefit to me. Maybe the cost down here is 9. I can sell it for 12. I earn $3. So I sell the first bushel, I sell the second one, the third one, the fourth one, the fifth one, because all of these bushels have the property that the price exceeds marginal cost. Right? You can see this difference right here. Sell the sixth bushel. Now the seventh bushel in this particular picture is I'm just kind of indifferent about selling it or not. If I decide to sell it, I make $12, but it costs me $12, 12 marginal dollars to produce that bushel. So I'm sort of indifferent about that one. We typically are going to assume that for this last one that the sale will be made, the profit will be the same either way. And so we end up with a projected best choice from the perspective of the firm of, I'm just going to call it little q star. Now it's important to note that there's a relationship between these two guys. And the relationship is that big Q star is equal to n, which is the number of firms, times little q star. So if n is, say, 100 firms, and if this is, 9, what do we say, 7, I guess. This is 7 bushels, then we know we can infer that over here this is 700 units. So that's how things work in terms of figuring out what the overall decision looks like. Now the last thing that we should add to this conversation is a discussion of profit. So I'm going to switch one more color one more time here, and I'm going to have you note that at our optimal quantity here of 7, or Q star if we want to be more generic, we can calculate not only the price of the good, but we can calculate the average cost of the good. Well, we know marginal cost is equal to price too. We can calculate the average cost of the good. And if I take and sort of project this line over, this average cost line, then I know that this is average cost when I plug in Q star, right? The average cost curve can be evaluated, this function, this one can be evaluated at any value, and I want to do it at this important optimal quantity. I know then that the difference between price and average cost is something I can think of as profit margin. So that's what the firm earns per unit, right? So that's profit margin. And that means if the vertical distance is profit margin, profit per unit, and this distance is quantity, then this area, colored in brown, this rectangle, represents profit to the firm. So the competitive firm here is earning positive profit to the tune of this much per unit times this many units, total amount here of this brown rectangle. Now there's one more thing that I'd like to talk you through, which is the long run adjustment process for perfect competition, in which case this profit rectangle is going to be under a bit of fire. To do that, I'm going to quick get us a clean screen, and then we'll go ahead and walk through the long run situation. All right, welcome back. Thought I would save us the time, and I've gone ahead and already drawn in another version of the same picture that we just left off from, showing a equilibrium at the market level over here of P star, and an equilibrium that gets projected, that price gets projected over to the firm level picture, where we find out that the firm wants to maximize its profits by producing more marginal revenue, which is equal to the price is equal to marginal cost. That sets this quantity, and then we calculate profit, which is this brown rectangle, at this optimal quantity. Now the question here has to do with long run equilibrium. So this is a situation that can persist in the short term. It's important to note, to talk about long run, that we remember that these costs, marginal cost and average cost, that these are calculated at their full opportunity cost values. So they include all the explicit stuff that you would expect, but they also include all the implicit stuff that probably you might not expect. So the time involved, the other financial opportunities you might have for your capital, things like that. So that's all included in these costs. So these values, these marginal and average cost curve numbers, are going to be higher than what you might expect if you were just thinking at it from an accounting perspective, for example. And that's going to be important for us here in just a second. So when we notice that this firm is earning positive profits, right, that price, the red line, exceeds average cost at the optimal quantity, so we have this brown area which is positive profit, this is a pretty significant sort of event. It's pretty nice to know that we have these positive profits here. So it means that the firm's earning returns above and beyond what they could earn in any other possible pursuit. So if this is a corn farmer, they're doing better by farming corn than they are by using their fields to do anything else. Farming soybeans, building small houses, whatever, it doesn't matter. This is the best thing that they can do by a sizable margin, and that's what shows up as this economic profit. Now, of course, the issue is that with free entry and exit, it's not going to take too long before other potential firms take a look at this and they say, well, I have costs that look like this. I could sell corn for this price, P star. I'd like to get my share of that profit. So what we're going to see, and remember the condition that we talked about, the condition is that under perfect competition, there's free entry and exit. And with that free entry and exit, what we're going to see is that new firms, because there's positive profits over here, right? So this particular picture as it stands right now shows profit. We use Greek or pi for profit sometimes. Profits that are positive, bigger than zero. So over here, what that's going to do is that's going to pull new firms into the market. And as new firms enter the market, what's going to happen is that the supply curve is going to shift to the right. So we have entry, call that S prime, that shifts the supply curve to the right. So that's entry of new firms. Now notice what it does is it pushes down on price. Right? So entry is going to depress price, right? We're going to slide down the demand curve, quantity demanded is going to increase, but the overall market price is going to decline. And what's going to happen over here, if I think about that price as it falls, as it comes down like this, is that my profit rectangle is going to shrink. It's going to get squeezed from above primarily, but I'm also going to slide down, the intersection is going to slide down this marginal cost curve. So that process will continue. I'll be able to tell you this entry story anytime profits are positive. Now likewise, I don't want to redo the picture again, but likewise, if we started off with costs that were quite high or prices that were very low, then we would have not the entry part of the story, but the exit part of the story. Firms would exit, the supply curve would shift the other way, prices would rise, and that loss or that negative profit would start to be eliminated. So when does that all stop? What's the only place where we don't have exit or entry? And the answer is the only place we don't have exit or entry is when profits are zero. So that's going to occur over in this picture when the price comes through and it's just, make this one nice and dark, it's just skimming along the bottom of that average cost curve. And all sorts of important stuff is happening right here, where the price comes through, crosses marginal cost, right at the spot where it crosses average cost. And that is going to be our example of long run equilibrium. And this long run equilibrium has the property that profit is equal to zero. And before you get too worried about, oh, how can a firm survive with zero profit? Before you get too worried about that, I'll just remind you again of this notion of opportunity cost. I like to think of the zero profit condition, maybe a better name for it is to think of it as a firm that's earning a normal rate of return. So they're not doing any better than they could in any other area. They're not doing any worse. They're just earning a normal rate of return. So that's how markets are going to turn out. Perfectly competitive markets are going to turn out in the long run. Short run profits are possible. Losses are possible for that matter. But in the long run, those profits and losses get eroded and get competed away because of entry and exit. Right? We'll see you soon from Monopoly. Thanks.